Hello dear friends. So I got one friend asking me to do a video of trigonometry, so why not try it? So this one is trigonometry proving law of sines and law of sine and cosine. Let me draw a triangle first. So here we have a triangle A, B, C, and this is a scalene triangle. It can be obtuse triangle, it can be acute triangle, but I just choose to make it an obtuse triangle. So now let me erase this one. We will work on this triangle. The law of sine is A over sine A equal B over sine B equal C over sine C. So we want to prove it. So here are three angles: A, B, C. They are different, so I have different line. If they are the same, I can do like this, and with one line to make sure that to illustrate they are the same. They are scalene or anything. So here we have A in opposite angle A opposite side A, angle B opposite side B, angle C opposite is side C, the side. So for this kind of problem, it's very hard to do it by itself. I think in any of the proving problems, you need to borrow some other elements to help you to solve the problem. For this one, we need to borrow something. And if we want to figure out the sine, then we need to make a right angle. So I will introduce a line, and this is the height. This height could be here. So this is 90 degrees. This is the height. This is the height. And this height, you can equally do another height here, 90 degrees. Make sure it is 90 degrees. And you can equally do another height here. You can do this red or blue height, but we leave it here. What we are going to use is only this height H. I will use red color for this height H. So in this triangle, we know in triangle we will add A, B, A, C, D. In triangle A, C, D. In triangle ACD, let's figure out ACD. Let's figure out the sine. Sine A is the height. Sine A is the height over the hypotenuse, which is B, 对边 B 斜边. So it's H over B. This is sine A. Okay, in this triangle, in triangle CBD or BCD, we will use the same thing, okay? BCD, in triangle BCD. Now let's figure out sine B. Sine B equal to 对边 opposite side over hypotenuse. So h opposite side is h. h over what is the hypotenuse? Hypotenuse is a over a. So up to here, we are pretty much enough in proving it, because the important thing here okay, so let me change into blue color. So in this one, what can we derive? We can derive h equal to b times sine a. And from this equation, we can derive h equal a times sine b. A times sine b. H is the same h. It is the same height. It's exactly the same, does not even need to change. So this, if this equation establish, it means the other side establish. So from these two, because, so what do we get? B times sine A equal to A times sine B. So let's divide the same thing. Divide B sine B. This one divide B sine B. Why do I choose it? It's just another way of doing it, because I want to figure out A over B. So here we can do the cross cancelling. We divide the same number. Did you see? I divide the same number. I did not change anything. This is an honest operation, right? So sine B and sine B on this side, we can cross cancel. B and B, we can cross cancel. What do we get? We get A over B equals sine A over sine B, or A over sine A equal B over sine B. Make sense? So A over B equal sine A over sine B. This is the normal algorithm or normal arithmetic, nothing fancy. A over, or A over sine A equal B over sine B. So the same method we can use in the other triangle, to figure out the relationship of B over B, B over C, and A over C. So it is the same method of proving it. So this is one of the proving of law of sine. Now I am going to do another video of law of cosine. Maybe I will just continue to do it. Okay, now let's try to attack the law of cosine. Cosine, make it a little bit larger, easier for us to see. The law of cosine, first let's state the law of cosine. A squared equal to b squared plus c squared minus 2bc cosine A. And all these three sides are equivalent, or not equivalent, are reciprocal. A, B will be the same thing. A squared plus c squared minus 2ac cosine B. C squared equal A squared plus B squared minus 2ab cosine C. So that's the law of cosine. There are different ways of writing it. You can put cosine A equal to whichever way you write it. This is the law of cosine. So I will draw a triangle to try to prove it. So let's do a blue triangle here. And I will make a scalene triangle. It's just easier that I make it into an acute triangle. It could be obtuse, it could be a right triangle. Anyway, so here we have a vertices A, B, C, and in opposite to angle A is side. Opposite angle B is side B. Angles opposite angle C is side C. And same as what we have done just now, whenever we try to prove something by itself is not easy. You need to borrow some outside element. That is, make a height here. So we make a height, and the problem will be much easier to be seen, and becomes much more possible, much more visible. So in this triangle ACD, let's continue. So this is the height. Height can be expressed in different way. I will want to express the height as within this BCD in triangle BCD. In this triangle, the height here we can write as A times, this is opposite, times sine B. A times sine B. And this part, what we can do, instead of writing it A cosine B, we can write it, this one is not instead, this one is A, this part, only this part, BD equal to A times cosine B. Let's write it down. The height CD equal A sine B. And BD equal A cosine B. They are both use the same hypotenuse, and it will be much easier to solve this problem. In the other one, I use this line and the other angle. It's not easy. At least there is some commonality. Here we have the commonality. They have the same hypotenuse. They have the same reference angle. It is very important. Now we need to introduce the element of C. Now when we do the proving part, we actually use the triangle ACD. Okay, so in triangle ACD, in this triangle, we know the height, which is still BC, CD, which is still CD. CD equal to A sine B, right? We know the CD, it is the same, no change. And AC, that's the tricky part. AD, not AC, because this is a small one. AC equal to the whole length AB minus BD. AD. Let me use eraser to erase it. Okay. AD equal to AB minus, oh, sorry, don't go. AB minus DB. AB minus DB. Right? The B get out. AD. So this is this. And in another expression, AB is C. Right? And DB is A cosine B. Voila. So in ACD, in this triangle, now we use hypotenuse, now we use Pythagorean rule, Pythagorean theory. So AC square equal to CD square plus AD square, right? So we can see B square in this triangle. Now shall we use blue pen to make us more comfortable? B square equal to CD square, the height is A sine B square plus AD square. AD is C minus A times cosine B square. Right? Now it's a pure mathematical calculation. I'll just open it up. Arithmetic. A square times sine square B square plus C square minus 2AC cosine B plus A square cosine B square. What do we see here? Sine B square plus cosine B square makes 1. So it becomes a square. Let me just move it a little bit. So I move this one here. And the rest I will continue to copy. Plus c squared minus 2ac cosine b, right? I didn't change anything, just move it here. So they have the same coefficient. Sine squared b plus cosine squared b makes 1. So this is a squared plus, this becomes a squared plus c squared minus 2ac cosine b. Ooh, are we getting there? We are getting there. So use red pen to write. B squared equal to a squared plus c squared minus 2ac cosine b. And you can, because all these angles are reciprocal, so you can prove b squared equal to a squared plus c squared minus 2ac cosine b. Anyway, thank you very, very much. And I have thought about it the whole day and didn't figure it out. Finally got it, and it made me happy. Bye bye, friends. I love you. I really do. Do.